Tonight, we are turning our attention towards something you have experienced thousands of times and never quite been able to explain. What is actually happening in the brain that makes a dream feel, in the moment of dreaming, as real as the room you are lying in right now? Science has been quietly answering that question for decades, and the answer turns out to be more intimate, more forgiving, and more human than most people expect. Welcome to Psychology for Sleep. Wherever you are right now, perhaps already settled into your pillow, your body beginning its slow release from the day. Allow yourself this particular kind of stillness. We'll drift through the corridors of 100 relaxing dream facts about the sleeping mind, from the architecture of the brain that builds entire worlds from nothing, to the quiet science of why some nights leave you breathless and others leave you rested, to the tender question of what it means that your mind never truly stops, even here, even now, even in the softest dark. This gentle journey through dream science is one that a lot of tired minds are searching for tonight. People who lie awake, wondering about their own inner worlds, who feel something when they dream and don't know what to do with it. A soft like or subscribe helps other sleepless souls find their way here too, and brings us closer to protecting this quiet space for every mind that needs it. One thoughtful tap is all it takes, because every person who finally rests here, that matters. Let yourself settle completely now. Feel the weight of your head against the pillow. Let your jaw unclench. Just slightly. Let your shoulders remember that they don't have to hold anything up right now. You don't need to follow every word tonight. You don't need to remember anything at all. Just let this move through you. The way a room feels after the last guest has gone. Still, unheld, and finally, only yours. Close your eyes and breathe deeply. You're resting where the body goes still and the mind goes somewhere else. Let your mind dissolve into the world. It was always building. And now we begin. Every night, you enter one of the most creative states your brain ever reaches. During dreaming, your mind constructs entire worlds, with landscapes, people, narrative, emotion, and physical sensation, from nothing but memory, biology, and electrical activity. You don't go somewhere else when you dream. You build somewhere else. From the inside out, scientists have come to understand that dreaming is one of the most complex things a human brain does. Not a passive experience, but a form of active, highly organized generation. Tonight, that process is already beginning. Dreams happen primarily during a stage of sleep called REM, which stands for rapid eye movement. During this stage, your eyes move beneath your closed eyelids. Your brain becomes nearly as active as it is when you are fully awake, and your body enters a state of voluntary muscle paralysis called REM atonia. This paralysis is protective. It prevents you from physically acting out what you are experiencing in the dream. Your brain is generating an entire reality. Your body wisely decides to stay very still. Tonight, that stillness is already beginning in your limbs. The feeling that a dream is real is not an accident or a flaw. It is a direct result of how the brain is structured during dreaming. The same sensory and emotional processing regions that respond to waking experience become active. The visual cortex fires, the auditory cortex fires, the emotional centers, particularly the amygdala, activate with the same intensity they would if you were actually seeing, hearing, and feeling those things. The brain does not mark dream experience differently from waking experience while it is happening. That is why it feels real, because neurologically, it is. A single night of sleep typically contains 4 to 6 separate REM periods. The first REM period lasts only about 10 minutes, but as the night progresses, each REM period grows longer. The final one before waking can last up to an hour. This means that the most vivid, most complex, most emotionally rich dreaming happens in the early morning hours. Just before you wake, the dreams you remember most clearly are almost always the ones closest to morning. Your brain saves its most elaborate storytelling for last. The visual experience of dreaming is generated almost entirely by the brain, without input from the eyes. During REM sleep, the thalamus, which normally acts as a gatekeeper, filtering sensory information from the outside world, partially shuts its gates to incoming signals. Instead, it begins to pass signals inward from memory, from emotion, from the brain's own internal patterns. The result is that the sleeping mind fills a visual field with imagery that feels just as textured, just as detailed, and just as present as anything you would see with your eyes open. Darkness outside, light inside. Most people dream in color. Studies that ask participants to record their dreams immediately upon waking consistently find that roughly 80% of reported dreams contain vivid color: red, blue, green, the full spectrum. Interestingly, research conducted in the mid-20th century found higher rates of black and white dreaming among older participants. And some researchers believe this may have been influenced by the black and white television and films those participants grew up with. What the eyes absorb through life may shape the palette the dreaming mind reaches for. The brain generates dreams with a narrative structure, even fragmented, even surreal. Dreams still tend to have a forward momentum, a sense of location, characters, and stakes. Researchers believe this narrative quality emerges from the brain's default mode network, a set of regions that becomes especially active during rest, and that is deeply involved in mind-wandering, imagination, and self-referential thought. When you dream, the default mode network runs something like an improvised story engine, stitching together memory fragments, emotional residue, and sensory impressions into something that feels like it is happening. You have dreamed thousands of times in your life. Neuroscientists estimate that the average person spends approximately 6 years of their life in the dreaming state across a typical lifespan. 6 years of generated worlds. 6 years of experiences that felt completely real in the moment they occurred. Most of them are now gone, dissolved upon waking, like something that was never there, and yet they shaped you, processed you, prepared you. 6 years of invisible work, done in the dark, while you thought you were simply sleeping. The reason dreams feel so emotionally intense is rooted in the activity of the amygdala. During REM sleep, the amygdala, the brain's primary emotion processing center, shows elevated activity compared to non-REM sleep, and in some studies, activity levels that match or exceed waking emotional processing. At the same time, The prefrontal cortex, the region responsible for rational evaluation, logical reasoning, and reality checking, becomes relatively quiet. This combination explains much of the dream experience, full emotional intensity, with reduced capacity to ask the question, wait, does this make sense? And here is where the central question begins to take shape. Your brain is not malfunctioning when it fails to recognize a dream as a dream. It is operating exactly as designed. The same systems that generate the experience of reality during the day, sensation, emotion, narrative, spatial awareness, are running during dreams. The only missing ingredient is the prefrontal brake that would otherwise say this cannot be happening. Without that brake, the experience is complete, whole, and in that wholeness, it feels real, because by every neurological measure your brain has available, it is. The physical sensations of dreaming are generated by the brain's body mapping regions. When you feel yourself running in a dream, the somatosensory cortex, the region that maps the body's surface and internal sensations, is generating that experience from memory and expectation. When you feel the texture of something in a dream, or the temperature of water, or the weight of something in your hands, those sensations are being constructed internally. They have no source outside the skull, and yet they feel, in the moment, as convincing as anything your skin has ever touched. Pain is rarely experienced during dreaming. Even in dreams involving injury or threat, researchers believe this may be related to the altered chemistry of REM sleep, including changes in serotonin and norepinephrine levels that dampen certain types of sensory transmission. This is, in a quiet way, a form of protection. The dreaming brain is willing to simulate danger, to generate fear, to create urgency, but it draws a kind of biological line at allowing full physical suffering during sleep. The body is protective of itself, even in its most creative state. The falling sensation that jolts many people awake at the edge of sleep is called a hypnic jerk. It occurs during the very first stage of sleep, not during REM dreaming, as the body begins its transition from waking to rest. The leading explanation is that the brain, sensing muscles relax all at once, briefly misreads that relaxation as a sign of falling. Some researchers connect this to our primate past, when sleeping in trees made a sudden muscle contraction genuinely useful. The exact reason remains gently uncertain. One of the quieter mysteries the sleeping body keeps to itself. Lucid dreaming. The experience of becoming aware that you are dreaming while remaining inside the dream has been scientifically verified since the 1970s, when psychologist Keith Hearn and later Stephen LeBerg used pre-agreed eye movement signals to demonstrate that sleeping participants could communicate their state of awareness in real time. More recent studies using neuroimaging have identified the specific brain changes associated with lucid dreaming, a temporary reactivation of prefrontal cortex regions that are otherwise quiet during REM. In a lucid dream, the reality checking system briefly wakes up while everything else stays asleep. The most common theme in dreams, across cultures and across age groups, is being chased. Falling is a close second. Flying, being lost, arriving unprepared for something. These recur in dream reports from every country, every language, every generation studied. The persistence of these themes across such diverse populations suggests they may be rooted in ancient survival programs encoded deep in the brain, primal simulations of threat, escape, and vulnerability that the dreaming mind runs and reruns regardless of the century you are living in. Something in the sleeping brain is still rehearsing for dangers it has never faced. The majority of people dream about people they know. Strangers appear too, and the brain generates their faces from composite memory without pulling from any specific individual. But familiar faces, familiar voices, familiar emotional tones dominate dream experience. Some researchers interpret this as evidence that dreaming is partly a social rehearsal, a system for practicing and re-examining human relationships, replaying emotional encounters, reprocessing interpersonal experiences that carry unresolved weight. The people who matter most to you during the day tend to find their way into the night. Dreams overwhelmingly occur in the first-person perspective. The dreamer experiences events through their own eyes, as protagonist, even when they have little agency or control over what is happening. This first-person quality is neurologically consistent with how the brain models the self in waking life, using a stable, continuous sense of self as the anchor of all experience. Even in sleep, even in fantasy, even in a world that follows no physical law, the self persists. You are always present in your own dreams. You cannot dream yourself away from yourself entirely. Dream amnesia, the rapid forgetting of dream content upon waking, is not a failure of memory. It is a designed feature of the sleeping brain. During REM sleep, levels of a neurotransmitter called norepinephrine, which plays a key role in encoding memories, are significantly reduced. This reduction is believed to be intentional. It allows the dreaming brain to simulate experience and process emotion without permanently overwriting the memory systems with the contents of every dream. The dreams that do cross into waking memory are often those containing the strongest emotional charge, the ones the brain may have marked as worth keeping. Blind individuals dream. Those who lose their sight after birth continue to experience visual dreams, sometimes for the rest of their lives. Those who have been blind from birth report rich dream experiences as well, but typically organized around sound, touch, smell, and spatial awareness, rather than vision. This tells us something quiet and important. The dreaming brain does not require sensory input to generate experience. It works with what it has. It shapes the dream around the architecture of the dreamer's particular life and finds a way to make it feel complete. Animals dream. This has been confirmed through decades of sleep research across species. Rats, when placed in mazes during the day, show hippocampal neural firing patterns during subsequent REM sleep that precisely replicate the patterns from maze navigation, as if the sleeping brain is rehearsing the route. Cats, in the 1960s, when the region suppressing movement during REM was surgically altered, appeared to stalk, pounce, and respond to invisible prey during sleep. Birds show REM-like brain activity. Octopuses, deeply distantly related to us, display rapid color changes across their skin during sleep that some researchers interpret as visual dreaming. Dreams, it seems, are not uniquely human. Newborn infants spend approximately 50% of their total sleep time in REM, compared to 20 to 25% for healthy adults. Some researchers have proposed that this elevated REM in early life serves a developmental function. The dreaming brain of an infant may be running simulations of sensory experience that help wire the developing nervous system before the child has enough lived experience to fill that time with memories. The infant dream, under this view, is not memory being processed. It is architecture being built. Dreams, in the very beginning, may help teach the brain how to be a brain. Dreaming engages the limbic system, the brain's emotional core, with a specificity that waking life sometimes cannot match. During REM sleep, emotional memories from recent experience are revisited within the low-stress chemical environment that sleep provides. Researcher Matthew Walker and his colleagues have proposed that REM sleep functions as a kind of overnight emotional processing, a period during which the brain returns to difficult experiences while the chemistry of distress is temporarily muted. This remains an active area of research, with scientists continuing to refine how exactly different sleep stages each play their part. What seems clear is that sleep, in its quietest hours, is doing something useful with whatever the day left behind. The experience of déjà vu, that uncanny feeling of having been somewhere or experienced something before, may be partly connected to the dreaming mind. Some instances of déjà vu appear to arise when waking experience closely matches dream content that was not consciously remembered. The new place, the unfamiliar conversation, the particular quality of light in a room. These may trigger partial recognition from a dream that dissolved before it could be held. You may have been here before, just not in the way you think. Sleep deprivation dramatically increases the intensity and strangeness of dreams when sleep is finally allowed. When the brain is deprived of REM sleep for even 1 or 2 nights, it compensates during recovery sleep with increased REM pressure, spending more time in REM than usual, and generating dreams of greater vividness and emotional intensity. This phenomenon, called REM rebound, suggests that dreaming is not optional. The brain pursues it. When REM sleep is taken away, the brain stores the debt and claims it back with interest the moment it is given the chance. And so we arrive at this: dreaming is not what happens when the brain rests. Dreaming is what the brain chooses to do with its most active, most chemically complex, most electrically alive periods of sleep. The body rests, the muscles still, the eyes close, and the brain, freed from the obligation of managing the outside world, turns inward and begins to build. What it builds, how it builds it, and why it feels so undeniably, uncomfortably, beautifully real. That is the question we are following tonight. Let's continue. Every cell in your body knows how to sleep. This state has been repeated millions of times before you were born. Your nervous system learned this rhythm from ancestors who knew nothing of neuroscience, nothing of REM, nothing of any of this. And yet they slept and dreamed and woke and carried that pattern forward until it reached you. Tonight, in this exact position, in this exact dark, you are doing the oldest thing a human body knows how to do. Let your breath slow. Let your muscles remember that they have permission to be completely still. Your body has done this 10,000 times. It knows the way. You don't have to lead it anywhere. Now we continue. The hippocampus, the brain region most critical for forming new memories, is highly active during REM sleep, but in a different pattern than during waking learning. During the day, the hippocampus encodes new information in a raw, episodic form. During sleep, it replays those encoded patterns, sending a shorter, more organized version of them outward to longer-term storage, like a rough draft becoming a final copy overnight. This replay process is believed to be central to how short-term memories become long-term ones. Dreaming may not just accompany memory consolidation. In some views, it may be part of the mechanism itself. The brain generates a chemical environment during REM sleep that is unlike any other state of consciousness. One chemical tied to attention and sensory awareness surges to high levels. Another, the one linked to alertness and clear memory, falls to its lowest point of the entire day. A third quietly steps back as well. The result is a brain that is perceptually activated, but without some of its usual anchors to the waking world. Some researchers describe the REM brain as being in a gentle, controlled state of deep internal sensitivity, vividly alert to its own generated content. Without the usual chemical weight of rational constraint, dreams do not always feel good. Fear is one of the most common emotions reported in dream content, appearing in approximately 65 to 70% of dreams in some research samples. Anxiety, confusion, sadness, and helplessness also appear frequently. Positive emotions, joy, wonder, affection, do occur. But the threat simulation hypothesis of dreaming suggests that the sleeping brain may have a particular appetite for rehearsing difficult situations. From an evolutionary perspective, a brain that spends its nights simulating escape, loss, and danger might be better prepared to navigate those experiences during the day. The dream is practice, even the frightening ones. The content of dreams shifts across a lifetime. Children tend to dream more frequently of animals and of threats, creatures, danger, being chased, than adults do. As people age, human characters gradually replace animals as the primary figures in dream narratives. Older adults tend to report fewer nightmares than younger people, and their dreams are described as less emotionally volatile. Some researchers interpret this developmental arc as evidence that the emotional regulation function of dreaming becomes more refined over time. The decades of nightly emotional processing gradually produce a dreaming mind that is, in some quiet way, more at peace with itself. Recurring dreams are among the most commonly reported dream experiences across all cultures. A person may dream the same scenario, the same house, the same chase, the same impossible journey, dozens or hundreds of times across a lifetime. Research suggests that recurring dreams tend to be linked to unresolved psychological tension, a concern, a fear, a relationship dynamic, an unanswered question in waking life that has not yet found its resolution. When the dreaming mind returns to the same terrain again and again, it may be asking the same question in different ways, waiting for the waking mind to finally hear it. The brain cannot read text reliably in a dream. If you look at a sign, a clock, a book page, or a phone screen within a dream, the words or numbers are almost always either unreadable, shifting, or different each time you look at them. This is because reading relies on a specific neural circuit involving the visual cortex and language processing areas that does not fully activate during REM sleep. The dreaming brain can generate the appearance of text. It knows what text looks like, but it cannot process what the text says. A dream clock shows time. The time changes every time you look. Smell is notably rare in dream experience. Studies consistently find that only a small percentage of dream reports include any olfactory component. This is thought to be related to the fact that the primary olfactory cortex, unlike visual and auditory areas, does not appear to be strongly driven by internal brain activity during REM sleep. The dreaming mind builds sight. It builds sound. It builds touch and emotion and physical sensation. But it rarely builds smell, which makes the moments when it does feel unexpectedly startling and precise and strange. Dream incorporation is the phenomenon by which sensory input from the external environment is woven into dream content in real time. If a phone buzzes nearby, it may appear in the dream as a sound of machinery or thunder. If your room is cold, you may find yourself in a dream landscape that is winter, or exposed, or wind-touched. If someone nearby speaks your name, it may be spoken by a dream figure. The sleeping brain is not entirely sealed from the outside world. It monitors incoming signal and folds what it notices into the story it is already telling. The boundary between outside and inside is not as firm as it appears. Nightmares are defined as dream experiences that are distressing enough to cause waking. They are distinct from bad dreams, which are distressing but do not disrupt sleep. Research estimates that approximately 5% of the adult population experiences frequent nightmares. At least once per week. Nightmares are more common in people experiencing stress, anxiety, post-traumatic responses, and certain medications including some antidepressants and blood pressure drugs. They peak in childhood, particularly between ages 3 and 6, and again in adolescence. The content of nightmares is surprisingly consistent across populations. Physical threat, helplessness, abandonment, and death appear most frequently. Nightmares that arise in the context of trauma have a distinct neural signature from ordinary nightmares. In trauma-related nightmares, the medial prefrontal cortex, a region involved in helping the brain recognize that a past threat belongs to the past, shows reduced activity. The dreaming brain revisits the difficult memory without the calming signal that would normally remind it this belongs to the past, not the present. That is what makes these particular dreams so difficult to leave behind. Some current treatments for trauma-related nightmares, including image rehearsal therapy, work by giving the waking mind tools to gently alter the dream narrative before sleep. There is a well-established phenomenon called the Tetris effect, named after the 1980s video game. People who spend extended periods engaged in a repetitive visual task, whether playing a video game, sorting items, or performing physical labor, often report seeing the imagery of that task replaying at the edges of sleep, in the hypnagogic state between waking and dreaming, or in early dreams. The brain, in its transition to sleep, appears to continue processing the most recent and most intensively rehearsed visual patterns. The last thing you do before sleep may be the first thing your sleeping brain reaches for. Some dreams involve conscious problem solving with measurable results. Multiple historical accounts, including those attributed to chemist Auguste Kekule, who reported arriving at the ring structure of benzene from a dream of a snake eating its tail, and to Paul McCartney, who reported waking with the melody of the song Yesterday fully formed, have been discussed in the context of creative incubation during sleep. More recent experimental work has found that participants who sleep on a problem, particularly during certain sleep stages, show improved performance on insight tasks. The sleeping brain, freed from the constraints of focused waking attention, sometimes finds the answer the waking mind had been looking past. The sense of time in dreams is difficult to calibrate from the outside. People sometimes report dreams that seem to span hours or days. Research using lucid dreaming, where participants could signal the beginning and end of a dream sequence with eye movements, suggests that dream time is roughly proportional to real time. A dream that lasts a few minutes in REM time tends to feel like a few minutes of dream experience, not hours. Very long-seeming dreams may be a product of memory compression during recall, or of how the waking mind stitches together fragments from multiple REM cycles into a single narrative. The dream is rarely as long as it feels. Sleep spindles, bursts of synchronized neural activity that appear during non-REM sleep, are associated with the quality of memory consolidation during sleep. Research has found that higher spindle activity during sleep is linked not only to better recall of factual information, but also to improved integration of new information into existing knowledge structures. This integration, connecting new to old, weaving recent experience into the larger map of what you already know, may be part of what makes morning feel different from the night before. You wake with more connections than you had when you closed your eyes. And here, at the midpoint of our evidence, something is becoming clear. The reason dreams feel real is not one thing. It is a convergence, the same sensory architecture activated, the same emotional intensity registered, the same narrative continuity maintained, all running without the one region that would recognize the experience as internally generated. The prefrontal cortex is quiet. The rest of the brain is fully awake. And in that strange and particular combination, a world is made that carries every quality of reality, except the one that would allow you to call it something else. Let's continue moving forward together. You're still here, still listening, still somewhere between thinking and resting. Take one slow breath. Your brain is doing exactly what it was built to do tonight. The facts are moving through you. The night is deepening, and we are moving through this together. Gently, without hurry. Let's keep going. The thalamus plays a role in dream vividness that researchers are still mapping carefully. During waking, the thalamus relays external sensory information to the cortex with high precision. During REM sleep, it shifts its relay inward, passing signals from the brainstem and limbic system upward, and generating what researchers sometimes call internally driven thalamocortical activation. This means the dream's visual, auditory, and sensory qualities are not random noise. They are organized signals, channeled through the same relay station that handles the signals from your eyes and ears during the day. The infrastructure of reality and the infrastructure of dreaming share the same wiring. The brain's default mode network, a set of interconnected regions active during rest, mind wandering, and self-referential thinking, overlap significantly with the regions most active during dreaming. This overlap has led some researchers to describe the dream as a form of intensified, immersive mind, wandering the default mode network, running without the interruption of external demands, generating experience at full resolution rather than the fragmentary flickers that characterize ordinary daydreaming. The dream may be what the mind naturally does when it is finally, completely, left alone. Dream content is influenced by culture, language, and lived environment. Studies comparing dream reports across different countries and cultural contexts find consistent differences in thematic emphasis. Dreams, from individuals in cultures with strong communal social structures, tend to include more group settings. Dreams from individuals in more individualistic cultural contexts tend to center on personal agency and singular narrative. The universal themes, being chased, falling, flying, persist across all groups. But the specific textures, the specific fears and desires and social landscapes of the dream, those are shaped by the life the dreamer has actually lived. Medication affects dreaming in measurable and sometimes significant ways. Drugs that influence the cholinergic system, including some medications used for Alzheimer's disease, can intensify REM sleep and dream vividness. Alcohol suppresses REM sleep in the first half of the night and is associated with REM rebound and vivid, sometimes disturbing, dreaming in the second half. Certain antidepressants, particularly those in the SSRI class, reduce REM sleep duration and can suppress dreaming almost entirely for some individuals. Beta blockers used for blood pressure can cause unusually vivid or disturbing nightmares in some patients. What goes into the body before sleep does not stay outside the dream. There is a specific type of sleep experience called a false awakening, in which a person dreams that they have woken up, gotten out of bed, perhaps spoken to another person, walked through familiar rooms, only to then actually wake and realize none of it occurred. False awakenings are more common during periods of disrupted sleep and appear to involve a kind of partial metacognitive awareness. The dreaming brain knows that sleep has been happening and generates a simulation of waking that is convincing enough to replace the real thing. Some individuals experience layered false awakenings, waking within a dream of waking, multiple times, before finally reaching the actual world. The dreams that stay with us longest are often those from the hours just before waking, and research points to why there is a well-documented pattern in which events from the previous 1 to 2 days tend to appear in dreams that night, or again 3 to 7 days later, in what researchers call a dream lag. The brain seems to return to emotionally significant experience in waves, touching it first in the immediate night, then revisiting it with more distance in the nights that follow. Dreaming is not immediate digestion. It is slow, repeated return, each time from a slightly different angle. People who report that they never dream are almost certainly dreaming. They are simply not recalling their dreams upon waking. Memory for dreams depends heavily on waking at the right moment, ideally during or immediately after a REM period, and on making an active effort to hold the dream before the recall window closes. Research in sleep laboratories, where participants are woken directly from REM sleep and immediately asked to report what they were experiencing, finds that virtually all participants report some form of dream content. The absence of dream memory is not the absence of dreaming, it is the absence of the moment of capture. The lateral prefrontal cortex, the region associated with critical reasoning, logical evaluation, and the ability to question one's own mental states, has been identified as a key differentiator between lucid and non-lucid dreaming. When this region reactivates during REM sleep, even partially, the dreamer becomes aware that they are dreaming. Practices aimed at inducing lucid dreaming, including reality checking throughout the day, mnemonic induction techniques, and certain wake-back-to-bed protocols, are thought to work by increasing the likelihood that this region will reactivate during the next REM period. The lucid dream is a regular dream with one additional light switched on. Shared themes in dreams often reflect shared human vulnerabilities. Across more than 70 years of systematic dream research, the most emotionally intense dream scenarios, being exposed, being unprepared, being lost, being unable to move or speak in a moment of danger, map directly onto fundamental human fears of social failure, physical vulnerability, and loss of control. The dreaming brain is not inventing these scenarios arbitrarily. It is drawing from a deep register of anxieties that are common to the species, fears that have been relevant to humans for as long as there have been humans. Your most frightening dreams may be the most universal things about you. Halfway through our journey, and the answer to the central question has begun to take shape. Dreams feel real because the brain uses the same reality construction machinery in both states. The visual cortex, the emotional processing centers, the narrative systems, the body map, all of them run during dreaming with the same authority they carry during the day. The only meaningful absence is the evaluative override, and without that one piece, the part that checks, the experience is indistinguishable from reality, not as an error, but as a consequence of how consciousness itself is built. Let's go deeper. The memory you believe most strongly right now, the one that feels most fixed, most certain, most yours, is actually reconstructed each time you recall it. Every act of remembering is an act of rebuilding. The brain does not retrieve a stored recording. It reassembles the experience from fragments, and in that reassembly, small things change. Right now, as you rest here, your brain is rewriting itself. Tonight is part of that draft. The version of you that wakes tomorrow will be slightly different from the one who lay down. This is not loss. This is how you continue to become. Take a slow breath. Let that process continue without your supervision. It knows what it's doing. Now we continue the journey. The question of why we dream at all remains one of the most genuinely open questions in neuroscience, not in a dismissive way, in a way that invites real curiosity. Multiple theories exist, each supported by evidence, none entirely complete. The threat simulation theory suggests dreams help us practice responses to danger. The memory consolidation view emphasizes the role of REM in long-term learning. The emotional regulation framework focuses on the overnight processing of difficult feelings. The most honest current position is that dreaming may serve several of these functions simultaneously, a multi-purpose tool that the brain found so useful it kept elaborating for millions of years. The activation synthesis model, proposed by psychiatrist J.W.W. Doddo, Alan Hobson, and researcher Robert McCarley in the late 1970s, described dreams as the brain's attempt to make meaning out of random neural signals generated during REM sleep. Under this model, the dreaming cortex receives bursts of electrical activity from the brainstem and constructs the most coherent narrative it can from that noise. This view gave birth to a useful way of thinking about dream strangeness. It is not symbolic or prophetic. It is the best story the mind could build from the materials it had on hand that night. Dreams as improvised fiction, generated under unusual conditions. More recent work has complicated and extended the activation synthesis view. Researchers, including Hobson himself, revised the model to emphasize that while the initial activation is driven by brainstem signals, the cortex's narrative construction is not random. It draws heavily on memory, emotional preoccupation, and recent experience. The dream is improvised. Yes, but it improvises from a specific set of materials that are not arbitrary. The strangeness is real, but the strangeness is also personal. Your dreams are strange in particular ways that are specifically yours. The hippocampus, during dreaming, replays memory sequences in a compressed and recombined form. A now well-established line of research shows that the hippocampus does not simply replay memories in order, it replays them in novel combinations, linking episodes that share spatial or emotional features regardless of when they originally occurred. This recombinatory replay may be part of how creative insight emerges from sleep. New connections are literally being drawn between memories that have never before been associated. The dream brain is not just remembering, it is connecting. It is finding patterns across the whole of a life. The sleeping mind tends to revisit emotionally significant events from the previous 1 to 2 days. A pattern researchers call the day residue effect. Events that carry emotional weight during the waking day are more likely to appear in dreams that night. The brain seems to process recent emotional experience in waves, touching it first in the night, immediately following, then revisiting it with more distance and context in subsequent nights. Dreaming is not immediate digestion. It is slow, repeated return, each time from a slightly different angle, and each return, perhaps, leaves the memory a little more integrated than it was before. The relationship between dreams and waking mood is bidirectional. Poor dream quality, fragmented sleep, frequent waking, nightmare, heavy nights, is associated with lower positive affect and higher emotional reactivity the following day. But waking mood also shapes dream content. People experiencing elevated anxiety or depression tend to report more threatening, more hopeless, and more negatively toned dreams. The mind brings its daytime weather into sleep and brings something of the sleep back out into the day. Dreams and mood are in continuous conversation, each shaping the other across the boundary of consciousness. Sleep spindles, slow wave oscillations, and sharp wave ripples, the 3 major electrical signatures of non-REM sleep, work together in a coordinated pattern that supports the movement of memory toward longer-term storage. Think of slow waves as setting the pace, while spindles provide the windows through which recently learned material can be passed along. This coordination happens quietly, every night, across the whole architecture of memory. The sleeping brain is not resting. It is running a highly organized transfer operation, moving what matters from the temporary into the lasting, prospective memory. the ability to remember to do something in the future, is influenced by sleep. Studies have found that sleep, particularly sleep containing REM and slow-wave stages, improves the probability of remembering planned intentions. The sleeping brain does not only consolidate what has happened, it also appears to maintain and strengthen the threads connecting the present to the future, the part of the mind that holds the shape of tomorrow. In some sense, while you sleep, you are also preparing for the day that has not yet arrived. The brain's response to faces during dreaming is consistent with its waking response. Neuroimaging studies of sleeping participants and lucid dreamers show that the fusiform face area, the region specialized for face recognition, activates during REM sleep when faces appear in dream content. Just as it does when faces are seen during waking, the face of a dream stranger triggers the same recognition machinery as the face of a real person. The dreaming mind does not flag the dream face as fictional. It processes it as it would process a face in a room, completely, automatically, without reservation. Certain neurological conditions offer vivid windows into the dream reality boundary. In REM sleep behavior disorder, the muscle atonia that normally paralyzes the body during REM sleep is absent or incomplete, and individuals physically act out their dreams, sometimes with great force. They may speak, yell, kick, punch, or flee, all while still asleep and dreaming. This condition makes visible what is normally invisible, that the dreaming brain is generating movement commands just as urgently as it generates the visual and emotional content of the dream. The only thing preventing those commands from becoming action, under normal circumstances, is a specific biological switch. The question of whether animals experience subjective dream experience, whether a sleeping dog is having something it would recognize as experience if it could report it, cannot be resolved with current methods. We can observe the neural correlates, the REM patterns, the behavioral indicators, the hippocampal replay. We cannot enter the experience. This limitation is not unique to dreaming. It is the central limitation of consciousness science in general. We cannot directly access another being's inner experience, human or otherwise. We can only observe from outside and draw careful, humble inferences. Dreams involving creative or artistic content, music, image, stories, solution, have been reported across cultures throughout recorded history. What sleep research suggests is not that the sleeping mind has special creative powers unavailable to the waking mind. Rather, it is that the sleeping mind has fewer constraints. It does not reject unusual combinations. It does not filter for social appropriateness or logical consistency. It is free to place things next to each other that waking thought would separate. And in that freedom, it sometimes finds something the waking mind, with all its caution, had been carefully looking past. The relationship between sleep and emotional memory is one of the most active areas of current research. Scientists are finding that different sleep stages, including both deep non-REM sleep and REM sleep, appear to play distinct but complementary roles in how difficult memories are stored and softened over time. Current thinking suggests that sleep may help preserve the information contained in a difficult experience, while gradually reducing its sharpest emotional edges. The picture is still being drawn, but the general direction is gentle sleep. in its various forms, appears to work quietly in our favor. The imagery of the hypnagogic state, the threshold between wakefulness and sleep, is distinct from full dreaming. Hypnagogic hallucinations tend to be fragmentary, geometric, rapidly shifting, and sometimes intensely visual flashes of color, abstract patterns, brief faces or landscapes appearing and dissolving. They occur as the brain begins to loosen its grip on external sensory anchors and starts generating internal signal. They are not yet the organized narrative of a full dream. They are the opening bars, the brain warming up the instruments before the full composition begins. We now understand something important. The dreaming brain is not a simplified or diminished version of the waking brain. In some respects, it is more active. In some respects, it is more free. It processes emotion with full intensity. It generates sensory experience with full detail. It constructs narrative with full coherence. What it lacks is not power but a specific editorial function, the capacity to step back and evaluate what it is generating against the standard of external reality. And without that one particular step back, the generated experience is indistinguishable from the world. This is not a limitation. This is a design. The brain's waste clearance network, sometimes called the glymphatic system, is most active during slow-wave sleep. The deep, non-REM stages that precede REM. During this clearance, cerebrospinal fluid moves through channels that expand as the brain cells themselves shift slightly during sleep. Among the byproducts cleared is amyloid beta, a protein associated with Alzheimer's disease when it accumulates. Sleep, including the deep stages that prepare the brain for dreaming, is a cleaning operation as much as it is a cognitive one. The brain that does not sleep well accumulates, night by night, a residue it was designed to clear. The sense of flying in dreams, one of the most commonly reported and most positively experienced dream themes, has been interpreted from multiple perspectives. Psychologically, it has been linked to feelings of liberation, freedom from constraint, and transcendence of ordinary limitations. Neurologically, it may be connected to the vestibular system, the inner ear's balance and orientation network, which continues processing during REM sleep without receiving its usual anchor of postural feedback from a body in motion. With no ground beneath you, with no gravity to calibrate against, the vestibular system may generate the sensation of movement through space, and the dreaming brain builds the narrative around it. Dream content can be gently influenced through pre-sleep intention. In a line of research going back several decades and refined in more recent work, participants who are asked before sleep to hold a particular image or emotion in mind as they drift off show measurable changes in the themes of their subsequent dream reports. This is not reliable or precise. The dreaming mind does not take instructions well, but it is more responsive to pre-sleep input than was once believed. What you carry into sleep is not always left at the door. Sometimes it follows you in. The amygdala, during REM sleep, responds to emotionally charged internal signals with the same rapid, automatic reactivity it shows during waking. But the medial prefrontal cortex, which normally modulates the amygdala's response, providing a kind of rational steadiness, is reduced in activity. The result is that dream emotion is experienced without the full regulatory counterweight Fear is felt as fear. Grief is felt as grief. Joy, when it comes, is felt as pure and simple joy. There is a kind of emotional honesty in the dreaming state that the waking mind, with all its regulation and compensation, does not always allow. Some dream content appears to be generated from a process that researchers call offline simulation, the brain running models of real-world scenarios using the same predictive systems that anticipate what will happen next during waking experience. Just as the waking brain constantly generates predictions about what the next moment will bring and then checks those predictions against incoming reality, the dreaming brain may run those predictive simulations without any incoming reality to check against. The result is a world that behaves almost like the real one, but not quite. A world that follows most of the rules and breaks them in particular ways, at particular moments, for reasons that the sleeping mind does not question. Research into lucid dreaming has begun to use it as a tool for investigating consciousness more broadly. Because lucid dreamers can signal their state in real time using eye movements, they provide a window into a form of metacognitive awareness that exists without waking external consciousness. Studies using electroencephalogram and neuroimaging during lucid dreaming have helped researchers map which aspects of self-awareness and reality monitoring depend on prefrontal reactivation and which can persist in its absence. Lucid dreaming is becoming a laboratory for one of the deepest questions in science. What exactly is the thing that knows it, is aware? Emotional residue from dreaming persists into waking. Most people have had the experience of waking from a dream they cannot fully remember, but carrying the emotional tone of it into the morning. A vague unease, an inexplicable sadness, or a warmth that feels sourceless. Neuroimaging research supports this. The emotional activation of REM sleep does not end cleanly at waking. There is a period of carryover, a lingering echo of the dream's emotional weather that influences mood and emotional reactivity for some time after waking. You may have already forgotten the dream before breakfast, but some part of you still knows you had it. The default mode network, active during dreaming, active during mind-wandering, active during self-reflection, has distinct hubs across the brain, including regions tied to memory, self-reference, and imagination. These regions tend to become synchronized in their activity during rest and dreaming. Some researchers describe this network as the seat of the narrative self, the part of the brain that weaves the past, the present, the imagined, and the anticipated into the continuous felt sense of being a person moving through time. The default mode network is, in some sense, where the story of you is written and rewritten. Every night, the question of whether dreams have meaning, in the sense of symbolic significance, in the sense of containing messages from one part of the mind to another, remains philosophically and empirically contested. What is not contested is that dreams draw from what matters to the dreamer. They are assembled from the dreamer's memories, the dreamer's fears, the dreamer's desires, and the dreamer's unresolved tensions. They may not be coded messages, but they are also not random. They are made of you, and in that sense, whatever is in them is yours. Something the sleeping mind was turning over, in its own particular language, in the particular dark of that particular night. The central question is answered now, intellectually. At least, dreams feel real because the brain uses the same architecture for both. The visual cortex generates the image, the amygdala generates the feeling, the narrative systems generate the story, the body map generates the sensation, the thalamus organizes and relays it all, and the prefrontal cortex, the one region that would recognize the experience as internal, is quiet. Every system that makes reality feel real is running. The one system that would say this is not real is asleep inside the sleep. What you experience is, therefore, complete. You simply cannot know, in the moment, that it isn't waking, and that is not a flaw. That is the design. Sleep doesn't come when you try to sleep. It comes when you stop trying, and you have already been moving in that direction tonight. With each breath a little slower, with each fact a little softer, with each passing minute, the thinking mind leaning a little more toward the edge of letting go. This is exactly that moment. There is nothing more to figure out tonight. Nothing to hold. Nothing to solve. Let go. The dream is already forming somewhere you can't see yet. The body knows where it's going. We'll continue with the final facts. Slowly, gently, almost all the way home, your brain will dream again tonight. Even now, as you grow heavier, as the words begin to soften at their edges, the machinery is preparing. You don't need to do anything to make it happen. You only need to stop. In a dream, you can meet someone you have never met. Your brain will construct their face, their voice, their way of moving through a room, entirely from nothing, and you will believe in them completely. For as long as the dream holds. This is one of the quiet wonders of the sleeping mind. Research suggests that the most emotionally significant dreams often occur in the final REM period of the night, the one closest to morning. By that time, the brain has had hours of preparation. The dreaming machinery is fully warmed. The stories that arrive then are often the most vivid, the most strange, the most difficult to shake. There are people who, for various neurological reasons, lose the ability to dream. Research on individuals with certain types of brain lesions, particularly those affecting the parieto-occipital junction, has found reported cessation of dreaming. These individuals do not report missing it at first, but follow-up studies suggest that some forms of emotional and creative processing that normally occur during dreaming appear to be diminished. The absence of dreams is not nothing. It is the absence of something the brain was quietly using. The REM rebound effect. The dramatic increase in dreaming intensity and duration that follows REM deprivation has been observed in virtually every mammalian species studied. Rats, cats, rabbits, monkeys, all of them, when denied REM sleep. I claim it back. The body does not negotiate this. It simply pursues it with increasing urgency until the debt is paid. The dream is not optional. It is a biological necessity that the body will find its way back to, no matter how long the path takes. The sense that a dream is deeply familiar, that you have dreamed this exact thing before, even if you cannot remember when, is common enough to have a name, déjà rêvé. From the French, already dreamed. It may arise from partial memory of a prior dream, or from the brain generating experience that matches the emotional pattern of many prior dreams. without matching any single one precisely. Something in the dreaming mind returns to certain territories, certain emotional climates, certain unresolved geographies. You cannot control the ending of a dream from within it. Unless you are lucid, the dreaming narrative has its own momentum, its own logic that feels completely inevitable while it is happening, and then it simply stops, or it shifts, or you wake, and the ending, which felt so final, dissolves along with everything else. Dreams do not have endings the way stories do. They have arrivals at waking. The older parts of the brain, the limbic system, the brainstem, the thalamus, drive much of the dream's content and intensity. The newer, more recently evolved, prefrontal regions are the ones that quiet down. In a sense, dreaming is a temporary return to an older form of mind, more emotional, more sensory, less analytical, more immediate. The dream is not where evolution went last. It may be closer to where it began. Some cultures treat dreams as significant communications from ancestors, from the sacred, from the future. Science cannot evaluate those claims directly. What science can say is that dreams carry real emotional content, real memory, and real meaning, and that they come from the most personal place the mind has. Whatever they are not nothing. The moment of recognizing a dream as a dream, the flash of lucidity, has been described by those who experience it as one of the most disorienting and gentle moments available to human consciousness. You are asleep. You are dreaming. And you know it. The world around you continues to feel completely real. And you are inside it. Awake, inside sleep, free inside the constraint of a story the sleeping brain is still telling. Two states of mind, briefly, inhabiting the same moment. Children who experience nightmares frequently tend to have richer, more vivid dream lives overall. Research suggests this is not simply a measure of distress. It may reflect a particularly active dream system, one that generates experience at high intensity across the full emotional spectrum. The same machinery that makes a nightmare difficult makes a beautiful dream beautiful. The vividness is not sorted by content. It is simply the power of the system, full on, in whatever direction the night decides to move. The last dream of the night is the one most likely to be remembered upon waking. This is partly a function of timing. It is closest to the surface of consciousness when the eyes open, but it is also related to the length and intensity of the final REM period. That last dream has had more time, more emotional accumulation, more narrative development. It is the one the dreaming mind had the longest to work on. And in the morning, it lingers, sometimes for minutes, sometimes for hours, before it finally, slowly, lets you go. Your brain creates entire worlds while you sleep. Every night, during REM sleep, your mind constructs vivid experiences from memory fragments, emotions, and patterns formed over a lifetime. Characters appear, conversations unfold, landscapes emerge, all generated from within. These dream worlds feel real in the moment, complete with sights, sounds, and physical sensations, yet they vanish upon waking, like morning mist. The sleeping brain is not resting, it is creating. The word dream appears in almost every human language, always carrying some sense of experience that is real in the moment and unreal in retrospect. The English word comes from an old High German root meaning joy. Music. Noise. The experience is ancient enough to have been named in every culture. The curiosity about it is ancient enough to have generated every mythology humanity has produced. Whatever dreams are, human beings have always known they were something. So why do dreams feel more real than reality? The answer is not that they are constructed more vividly. It is that they are constructed with the same tools, the same sensory systems, the same emotional intensity, the same narrative continuity, but without the mechanism that compares experience to external reality as a check. In waking, the brain is constantly calibrating. This is what I expect. This is what I find. This is real. In dreaming, only the first half of that process runs. The experience is generated, but it is never checked, and so it arrives. Complete, unchallenged, entirely itself. In some traditions, personal impression, not scientific claim. The dream is understood as the place where the mind is most honest, without social performance, without the management of impression, without the filters the waking self maintains to move through the day, just the raw material of a mind left alone with itself in the dark. Whether or not that honesty carries meaning, that is a question each person carries into sleep with them, unanswered. The brain during dreaming is doing something that nothing else does quite the same way, generating a complete subjective world from the inside. A world with texture and time and feeling and consequence, without any external source. This is, in its quiet way, worth noticing, not in a way that requires excitement, just in the way that a very old and very reliable thing can be worth noticing. The dreaming brain has been doing this for millions of years. It has had a long time to get good at it. The boundary between the dream and the waking world is crossed twice each night, or 4 times, or 6, depending on how many REM cycles the night contains. Each crossing is a kind of threshold, and in the crossing, things are sometimes lost. The dream dissolving as the eyes adjust to the room, to the ceiling, to the familiar edges of the life that is actually happening. The threshold is not dramatic. Most of the time, you don't even notice crossing it. You simply find yourself on the other side. Memory researchers sometimes speak of the sleeping brain as a narrator, a system that takes the raw, fragmented experience of a day and turns it into something it can use, organized, connected, integrated into the longer story of a life. If that is what dreams are, narrative processing, identity, consolidation, the ongoing work of becoming, then dreaming is not something that happens to you. It is something you do, every night, in the dark, without knowing. The very last fact tonight is not a number or a study or a name. It is an observation, offered quietly, as something worth carrying into sleep. The fact that a dream can feel more real than reality is not evidence that reality is fragile. It is evidence that the brain is extraordinary. It can generate the full texture of existence from within itself. It can build a world complete enough to be lived in, and then it opens its eyes, releases the world it made, and begins again. It does this every night. It will do it again tonight, and the world it makes, for however long it lasts, is yours. And so, our quiet journey through the dreaming mind comes gently to a close. We began where so many nights begin, with the question of why the mind at rest is capable of generating experience so complete that it cannot tell itself apart from waking. We followed that question into the amygdala running at full intensity, while the prefrontal cortex grew quiet. We traced it through the hippocampus, replaying memory in novel combinations in the deep hours before morning. We held it against the image of an infant, spending half its sleep in REM, a developing brain building its own architecture from the inside. And somewhere in the 95th fact, we arrived at something simple and true. The sleeping brain is not resting. It is creating. That is not a scientific conclusion. It is also not a metaphor. It is both things at once, which may be the most honest thing that can be said about a mind building worlds in the dark. Perhaps that is worth sleeping on tonight. Dreams remind us that the mind is never entirely still, that even in its quietest hours, it is tending to something, sorting, connecting, revisiting, building. Much of this happens without your knowledge, without your direction. In the particular silence that belongs only to sleep, the dream does not ask permission to begin. It does not explain itself when it ends. It simply arrives, does what it came to do, and releases you back into the morning, slightly changed, even when you can't say exactly how. By pausing to notice that we glimpse something quiet and extraordinary in the most ordinary thing we do. In these final minutes, take the deepest breath you can, as deep as possible. Think about the dreaming mind, yours, and every other mind lying in the dark tonight, all over the world, in every time zone, in every language, all of them building worlds in the same darkness, with the same tools, toward the same quiet dissolution of waking, the strangeness of a dream that felt completely real, the grief of watching it dissolve, the curiosity of not quite knowing where it went. These are not yours alone. They belong to the species. Let your entire being dissolve into the space between waking and sleeping, where thought becomes image, where image becomes feeling, where feeling becomes nothing, and nothing becomes rest. Prepare for deep sleep. No boundaries left, only peace. This gentle exploration of the dreaming mind was made for every restless person who has ever wondered about their own inner world. A quiet like or subscribe helps another searching mind find its way here, and brings one more person closer to the sleep they have been looking for. Tonight, and every night after, the dream is still forming, somewhere you haven't reached yet. Your body knows the way there. It has made this journey many thousands of times before. You don't need to hold any of what we covered tonight. The facts were never really the point. The point was this: the slow settling of the breath, the heaviness behind the eyes, the gradual loosening of the day from everything it had been holding. You can allow these thoughts of dreaming to fade now, like the last image before waking, present, then softer, then simply part of everything, leaving only the quiet, unheld calm behind. Let your breathing deepen. Let your body feel heavier, as if all you've been carrying today is being sorted by careful, invisible hands, and is simply setting itself down. If sleep comes, let it carry you the way consolidation does, not with force, but with quiet intention. into a realm where time and weight no longer matter. If your eyes are still open, the next video is waiting for you, ready to continue the journey. But if they're closed, stay there. Stay in the darkness that feels safe and warm. Tomorrow, the questions will still be there. The mystery of your own sleeping mind will still be turning, still becoming. But tonight belongs to stillness. Rest well, gentle explorer. And remember, your mind is always turning toward the calm. Good night.